Hello and welcome to Space for Sleep. I'm so glad you're here. Whether you're settling into bed, curling up on the couch, or just trying to wind down after a long day of pondering the mysteries of existence, you've come to the right place. This is a quiet corner of the internet where science slows down and the cosmos speaks softly. Tonight, we're exploring one of the most breathtaking events the universe has ever staged, when two galaxies collide. Before we begin, take a moment to subscribe and hit that like button. It helps this channel grow and brings more of the universe right to your screen, one calm, fascinating mystery at a time. Now, imagine this. You look up at the night sky. Thousands of stars shimmer quietly above you. It feels eternal, still, peaceful. But what if I told you that everything you're seeing is in motion? That our entire galaxy, the Milky Way, is racing through space at hundreds of thousands of miles per hour, and not just moving, but on a slow, inevitable collision course with another vast island of stars, the Andromeda Galaxy. It sounds like a scene from a science fiction movie, but it's real. The Milky Way and Andromeda are drifting closer every second. Across the unimaginable distances of space, gravity is pulling them toward each other, like two cosmic dancers locked in a slow waltz that's been choreographed since the dawn of time. And here's the part that's hardest to grasp. This collision has already begun, in the subtlest way possible. The outer edges of both galaxies, their invisible halos of dark matter, have started to interact. The stage is set for a drama that will unfold over billions of years. But what actually happens when two galaxies collide? Does everything explode? Do stars crash into one another like cars on a highway? Surprisingly, no. Space, even inside galaxies, is almost entirely empty. When two galaxies merge, their stars almost never physically hit. Instead, gravity weaves them together, distorting, stretching, and reshaping both galaxies in an extraordinary dance that transforms everything. To understand what that means, imagine 1 trillion tiny points of light, stars, planets, nebulae, all moving under the gentle but relentless pull of gravity. When one galaxy's gravity brushes against another's, it's like a tidal wave spreading through a cosmic ocean. Great arcs of stars are pulled outward, forming bridges and tails that stretch across hundreds of thousands of light years. The galaxies twist and warp, creating shapes so strange and beautiful they almost seem alive. If you've ever seen the antennae galaxies, those two dazzling swirls of starlight colliding 45 million light-years away, you've already witnessed what the Milky Way and Andromeda will become. In those vast, glowing arms of gas and dust, new stars are being born by the millions. The collision compresses clouds of hydrogen, sparking waves of star formation, bright blue newborn stars that light up the chaos like fireworks in slow motion. It's violent and creative at the same time. Every burst of new light is also a reminder of cosmic destruction. Because for new stars to form, old structures must be torn apart. Entire star systems are flung into intergalactic space. Some may wander alone forever, drifting between galaxies. Others will fall inward, captured by the growing gravity of a new, larger galaxy being born from the merger. At the heart of each galaxy lies something even more mysterious. A supermassive black hole. These titans, millions or even billions of times more massive than our sun, are the silent anchors that keep galaxies together. When two galaxies collide, their black holes slowly spiral toward each other, drawn together over hundreds of millions of years. Eventually, they merge, releasing an immense burst of gravitational waves that ripple through the fabric of space-time itself. Someday, our galaxy's own black hole, Sagittarius A, will meet Andromeda's. The energy from that merger will shake the universe, and though we won't feel it here on Earth, the waves will echo across billions of light years. But don't worry, this isn't a doomsday prophecy. The Milky Way-Andromeda collision won't happen for another 4-5 billion years. By that time, our sun will be nearing the end of its life, transforming into a red giant. Earth as we know it may no longer exist. But the beauty of this story is that the universe continues, reshaping itself endlessly, From destruction comes creation. From chaos, order. When the two galaxies finally combine, they'll form a single massive elliptical galaxy, often called Milkomeda by astronomers. It will shine brighter and larger than anything the night sky has ever seen. If there are still beings alive somewhere within it, they might look up and see a sky filled with billions more stars than we do today. A sky glowing with light from the union of two ancient galaxies. Think about that for a moment. The same gravity that keeps your feet on the ground, that pulls an apple from a tree, is also guiding galaxies across the vastness of the universe. The laws of physics don't change. They just play out on a scale that's almost impossible for the human mind to imagine. Our universe is not static. It's a living, breathing expanse of constant motion. Every atom, every planet, every galaxy, all part of an intricate, interconnected story billions of years in the making. When two galaxies collide, it's not destruction in the way we think of it. It's transformation, a natural part of the cosmic cycle that's been repeating since the beginning of time. If we could somehow speed up time and watch the universe from afar, we'd see a breathtaking ballet. Galaxies swirling, merging, separating, and reforming like waves in an endless ocean of light. Each collision creates something new stars, new worlds, new possibilities for life. And perhaps, one day, someone in another galaxy will look up at their sky and wonder how their home came to be, never realizing that it was born from the same kind of collision we're awaiting now. So, as you sit here tonight, staring into the dark, remember that you're part of this cosmic story. The atoms in your body were once forged in ancient stars, maybe even stars that collided long ago in galaxies that no longer exist. You are, quite literally, the universe becoming aware of itself. That's the true wonder of it all. The same forces that shape galaxies also shaped you. And in every sense that matters, you are made of stardust. Still moving, still evolving, still part of the greatest story ever told, the story of the cosmos itself. If this journey through space and time made you feel a little more connected to the universe tonight, don't forget to subscribe and join our growing community of curious minds. There's so much more to explore, from the smallest particles of quantum mechanics to the grandest galaxies that light up the heavens. Until next time, keep wondering, keep looking up, and remember, every star you see is part of an endless dance, a slow, silent symphony of creation that never truly ends. If we're going to understand what really happens when galaxies collide, we first need to understand what a galaxy truly is. When we look at those spiraling arms of stars through telescopes or deep space photographs, it's easy to think of a galaxy as a single object, like a planet or a sun. But a galaxy is not one thing. It's a vast, sprawling ecosystem of billions, sometimes trillions of stars, planets, gas, dust, and dark matter, all bound together by gravity, moving together like a cosmic city drifting through the night. The Milky Way, our home, is one of these great islands in the cosmic ocean. It stretches more than 100,000 light-years across. If you could travel at the speed of light, nearly 300,000 kilometers per second, it would still take you 100,000 years to cross from one side of our galaxy to the other. And yet, when we gaze up at the stars, it feels so close, so intimate, like we're right in the middle of it all. And in a way, we are. Every galaxy has its own shape, its own personality. Some are smooth and round, like glowing orbs. These are the elliptical galaxies. Others, like the Milky Way, are spirals, elegant, flat disks with sweeping arms of stars curling gracefully around their centers. There are also irregular galaxies, strange and chaotic, twisted by collisions and gravity until they no longer resemble anything familiar. But hidden beneath all of this light is something invisible, a vast halo of dark matter. This mysterious substance doesn't emit or reflect light, but it makes up most of a galaxy's mass. Without dark matter, galaxies wouldn't hold together. The stars would fly apart, their motion too fast for visible gravity alone to contain them. Dark matter is like an invisible skeleton, a cosmic scaffolding that shapes and stabilizes the visible universe. When two galaxies begin to collide, it's not just their stars and gas that interact. Their dark matter halos, massive, unseen, and extending far beyond what we can see, are the first to touch. Imagine two invisible clouds overlapping long before their bright centers meet. It's there, in that ghostly contact, that the gravitational tug-of-war begins. Over millions of years, the outer regions of both galaxies start to feel the pull. The balance that once held each galaxy's shape begins to falter. Tides of gravity stretch and twist the edges, creating long streams of stars, like ribbons of light drifting into space. The galaxies begin to warp, their symmetry breaking apart as they spiral around one another in a slow, majestic embrace. This is not an instant event. It's a process that unfolds over hundreds of millions, even billions of years. To our human perspective, it's almost unimaginably slow, a dance so vast that no civilization, no species could ever witness it from start to finish. Yet, through the lens of physics, this is motion at its most powerful and transformative. If you could somehow stand outside the universe and watch it all happen in fast forward, you'd see galaxies colliding like soap bubbles drifting together in space. They meet, they merge, they stretch and twist, and eventually they become one. It's not destruction, it's metamorphosis. The first close pass between two galaxies can be spectacular. As their gravity intertwines, the gas within each galaxy, the raw material for stars, begins to compress. Clouds of hydrogen and helium collapse under their own weight, igniting new waves of star formation. These are called starburst regions, dazzling areas where thousands of new stars are born at once. The light from these young stars is fierce and blue, cutting through the cosmic darkness. For a while, the merging galaxies shine brighter than ever. Astronomers have seen this many times. In the antennae galaxies, the mice galaxies, the whirlpool galaxy. Each one tells a similar story, chaos and beauty intertwined, destruction giving rise to creation. And then there's the silence. Between those bursts of light, most of space remains empty. Even when galaxies collide, the stars themselves almost never touch. The distances between them are simply too vast. If the sun were the size of a grain of sand, the nearest star would be several kilometers away. In a galactic collision, stars weave past one another like ghosts, close enough to feel each other's pull, but not enough to collide. What does collide are the vast clouds of gas and dust that float between the stars. When these clouds smash together, they compress violently, triggering those brilliant waves of star formation. In some regions, entire clusters of stars are born, miniature galaxies within galaxies, glowing for millions of years before fading back into the quiet fabric of the cosmos. As the two galaxies continue to interact, their shapes distort further. One might develop long tidal tails, thin arms of stars stretching out for hundreds of thousands of light years. Another might be stripped of its outer layers entirely. Slowly, their individual identities begin to blur. What were once two distinct galaxies become one vast, turbulent system, their stars mixing, their black holes inching closer together at the center. It's easy to forget that everything we see in those distant images from Hubble or the James Webb Space Telescope is ancient history. Light takes millions, sometimes hundreds of millions of years to reach us. When we look at a colliding pair of galaxies, we're not seeing what's happening now. We're seeing what happened eons ago. By the time that light finally touches our eyes or our senses, those galaxies have already changed, merged, or evolved into something entirely new. That's one of the most beautiful and haunting truths of astronomy. Every image is a glimpse into the past. The universe is a vast time machine, and we're always looking backward. When we see galaxies colliding in deep space, we're witnessing events that may have taken place long before Earth even existed. And yet, in that ancient light, we find the clues to our own future. Because the Milky Way and Andromeda are on the same path, a slow but certain journey toward each other. The story of galactic collisions isn't just happening out there, in distant corners of the cosmos. It's happening here too, quietly unfolding over billions of years, in the very sky above our heads. Some astronomers call it destiny. Others call it inevitability. But whatever we name it, it's one of the most profound realities of existence. Even galaxies, the largest structures in the universe, are not permanent. Everything moves, everything changes, and everything, in time, merges back into the greater whole. The next time you look up at the stars, remember this: the peaceful sky you see tonight is not fixed. Every point of light is in motion, every pattern is temporary. The constellations you recognize will fade, drift, and vanish as our galaxy reshapes itself over cosmic time. One day, far in the future, the sky above Earth will look completely different, brighter, stranger, and more crowded with stars than ever before. And in that distant night, whoever looks up at the heavens will be seeing the result of a collision that began long before they were born, a collision written into the fabric of the universe itself. So when galaxies collide, it's not just a cosmic event. It's a reminder, a whisper from the universe that change is inevitable, that even the grandest structures are part of a cycle that never ends. Galaxies are born, they grow, they merge, and they evolve, just like everything else in nature, just like us. When two galaxies begin their long approach, it isn't sudden or violent. It's subtle, an invisible dance guided entirely by gravity. Over millions of years, they begin to feel each other's pull, shifting ever so slightly from their original paths. At first, they move gracefully, like two distant dancers drawn together by an unseen rhythm. But as they draw closer, that rhythm changes. The dance becomes more intricate, more intense. The first contact between galaxies happens long before their stars ever mingle. It begins with gravity. This invisible force, the same one that holds your feet to the ground, reaches across unimaginable distances. It's patient, it's relentless, and it never stops pulling. As the galaxies approach, their gravitational fields start to distort each other. The balance each one held for billions of years begins to crumble. The stars on the outer edges are the first to feel it. They're tugged, stretched, and pulled outward, creating delicate tidal tails that sweep through space like streams of cosmic silk. To the human eye, seen through a telescope, these structures look almost painterly, like brushstrokes of light against the darkness. The galaxies continue their approach, and soon, their mutual gravity begins to twist them apart. Entire spiral arms may unravel. Clusters of stars are thrown outward into intergalactic space, destined to drift alone for eternity. Others fall inward, captured by the deepening gravitational well at the center of the merging system. The galaxies begin to spin around one another, caught in a gravitational embrace that will last for hundreds of millions of years. To us, this would appear motionless, frozen. But on cosmic timescales, it's anything but. If you could speed up time, you'd see the galaxies sway, distort, and merge like living creatures. Their cores spiral closer, drawn together by their own immense gravity. Each pass brings them closer still, until they finally unite in one colossal wave of transformation. The process might sound destructive, and in a way, it is. Yet in that destruction, something extraordinary happens: creation. When the gas clouds inside each galaxy collide, they compress and collapse, igniting countless new stars. For a brief time, the merging galaxies become some of the brightest objects in the universe. Their star-forming regions flare to life, burning blue and white in the darkness. It's as if the universe itself is celebrating, turning chaos into light. Astronomers have watched these events play out through powerful telescopes. The Hubble Space Telescope has captured images of galaxies mid-collision, their shapes warped and tangled, their cores glowing fiercely. The Antennae galaxies are among the most famous. Two spiraling systems so entwined that they look like a single explosion frozen in time. Their name comes from the long arcs of stars flung outward during their encounter. Glowing tendrils that stretch for hundreds of thousands of light years. In those regions, stars are being born at an astonishing rate, up to 1,000 times faster than in our Milky Way. But not all of those stars will survive for long. The most massive among them will burn brightly for only a few million years before collapsing in spectacular supernova explosions. Those explosions will scatter heavy elements, carbon, oxygen, iron, into the interstellar medium, seeding the raw materials for future stars, planets, and maybe even life. So in this grand dance of destruction, there's also renewal. The universe wastes nothing. Every end is also a beginning. But while stars are being born in abundance, there's something else happening deep within the merging galaxies, something far more mysterious and powerful. At the center of nearly every large galaxy lies a supermassive black hole. When two galaxies merge, their black holes begin an inevitable journey toward each other. They spiral inward, slowly at first, then faster and faster as they draw closer. When they finally meet, they merge into one even larger black hole, releasing a burst of gravitational waves, ripples in space-time that travel across the universe. These waves are so faint, so subtle, that only the most sensitive instruments can detect them. But they carry with them the memory of the collision, the story of two galaxies becoming one. Even as the galaxies merge, their individual stars continue their motion, obeying the timeless laws of physics. Some are thrown into long, looping orbits, flung to the outer edges of the new galaxy. Others sink toward the center, joining the dense cluster around the black hole. The combined system begins to settle into a new shape, rounder and smoother than before. Over billions of years, the once spiral galaxies transform into a single, massive, elliptical galaxy. The silent, glowing remnant of the cosmic collision. The Milky Way and Andromeda are destined for this same fate. When they finally meet, their first close pass will send ripples through both galaxies. The night sky, for anyone alive to see it, will be breathtaking. Andromeda will stretch across the heavens, its bright core glowing like a ghostly cloud. Over millions of years, the two galaxies will weave together, their shapes distorted, their stars rearranged. The sky will become a canvas of color and motion, unlike anything we can imagine. And yet, for all the drama, the solar system will probably survive. The chances of the sun colliding with another star are so small, they're almost non-existent. Space is simply too vast, but our night sky will never be the same. Future observers, perhaps artificial intelligence or distant descendants of humanity, will look up and see a sky filled with billions of new stars, a sea of light created by the merger of two galaxies that once stood apart. It's humbling, isn't it? The idea that even on the grandest scale, the universe is in constant motion. That the same gravity that keeps the moon circling Earth also binds galaxies together over cosmic distances. Everything, from the smallest atom to the largest structure in the universe, follows the same rules, the same elegant dance. Galactic collisions remind us that nothing in the universe stands still. Change is not the exception, it's the rule. From the collapse of a single hydrogen cloud to the merging of entire galaxies, creation and destruction are one continuous process. If you could watch the universe evolve in fast motion, it wouldn't look violent. It would look like art. A luminous, swirling ballet of light and gravity, a dance without a beginning or an end, only endless transformation. When you think of it that way, a galactic collision isn't something to fear. It's a reminder of the universe's extraordinary patience. These transformations take billions of years, longer than the entire history of life on Earth. Yet every step is purposeful, every movement precise. So the next time you see an image of two galaxies colliding, those arcs of light, those spiraling clouds, remember, you're looking at one of the universe's greatest love stories. Two immense systems, each with their own history, each filled with countless worlds, slowly becoming one, not through chaos, but through gravity, not through violence, but through connection. And that, perhaps, is the most poetic truth of all. In the vast silence of space, creation is born from union. Even in the cold emptiness between stars, the universe is always reaching, always drawing things together. Galaxies, matter, energy, even us. If this moment of the cosmic dance leaves you in awe, take a second to subscribe and stay with us, because every episode we explore here brings you closer to the heart of the universe, where every collision, every spark, every quiet drift of starlight is part of the same grand story, the story of everything. When we look at galaxies through telescopes, we see beauty, glowing stars, shining nebulae, bright clusters spiraling through space. But everything we see is only a tiny fraction of what's really there. The universe hides most of itself in darkness. Not the darkness of empty space, but a deeper, invisible kind. A kind made of something we can't see, can't touch, and can't yet fully explain. It's called dark matter, and without it, galaxies wouldn't exist at all. For decades, astronomers thought galaxies were held together solely by the gravity of their stars, planets, and gas. But when they measured how fast galaxies spin, they discovered something strange. The outer stars were moving far too quickly. According to the known laws of gravity, they should have been flung off into space. But they weren't. The galaxies were holding together, as if some unseen mass was keeping them intact. That invisible mass became one of science's greatest mysteries. It doesn't emit light, it doesn't absorb it, but it has gravity, and lots of it. About 85% of the matter in the universe is dark matter. Everything we see, stars, planets, galaxies, even you, makes up less than 15% of what actually exists. Think about that. Most of the universe is invisible. When two galaxies collide, it's not just their visible parts that interact. Their dark matter halos, these massive, invisible spheres surrounding each galaxy, are the first to meet. They overlap long before the glowing arms of stars ever touch. Imagine two enormous, transparent clouds merging in the dark. Their combined gravity begins to tug on everything inside. Stars, gas, dust, shaping how the visible collision unfolds. Dark matter acts like the skeleton of the universe. It doesn't crash or collide like ordinary matter does. Instead, it passes through itself silently, its gravity continuing to guide the motion of galaxies as they blend together. It's as though an invisible hand choreographs the dance, unseen but absolutely in control. Astronomers have confirmed this through breathtaking observations. One of the most famous is called the Bullet Cluster. Two colliding clusters of galaxies about 3.8 billion light-years away. When scientists observed it, they saw something astonishing. The gas, the visible matter, had collided and slowed down, but the bulk of the mass, detected through gravitational lensing, had passed straight through. The visible material and the dark matter had separated, moving apart like two layers of reality drifting through each other. It was one of the clearest pieces of evidence that dark matter is real. Not just a theory, but an unseen presence shaping the universe. Now imagine that on the scale of a galactic merger. The dark matter halos of both galaxies don't just influence where the stars go, they dictate the entire choreography of the collision. They pull, stretch, and anchor the galaxies, ensuring that the resulting shape, the new merged galaxy, is stable. Without dark matter, galaxies might simply fly apart, their stars scattering across space. But because of it, the merger settles into a graceful new form, bound together for billions of years. The idea that something so vast and powerful is completely invisible feels almost mystical. And yet, it's grounded in physics. We know dark matter must exist because of how it bends light, how it moves galaxies, and how it shapes the large-scale structure of the universe. If we could see it, the night sky would look utterly different. We'd see enormous webs of invisible matter stretching across the cosmos, filaments connecting galaxies like threads in a cosmic tapestry. Those filaments are where galaxies are born. They form at the intersections of these invisible webs, where dark matter's gravity pulls gas and dust together until stars ignite. So when galaxies collide, it's not just two isolated systems meeting. It's two parts of this larger structure merging and evolving together. You could say dark matter is the quiet architect of the universe. It never shines, never explodes, never calls attention to itself. But without it, there would be no galaxies, no stars, no collisions, no us. And as mysterious as it is, dark matter may not even be the whole story, because alongside it exists another enigma, dark energy, a force that does the opposite. While dark matter pulls things together, dark energy pushes them apart, driving the expansion of the universe ever faster. These two cosmic forces, one binding, one separating, shape the destiny of everything that exists. In a galactic collision, dark matter's role is subtle but profound. As the galaxies merge, their halos combine, forming a single, more massive dark matter envelope that holds the new galaxy together. Over billions of years, the stars settle into orbits within that invisible framework. The chaos quiets, the light fades, and what's left is a stable, luminous remnant, calm on the surface but supported by a vast, unseen foundation. The irony is beautiful. The brightest events in the universe, the merging of galaxies, the birth of stars, all depend on something we can't see at all. It's a reminder that the universe isn't just what meets the eye. It's deeper, stranger, and more interconnected than we can imagine. When you think about dark matter, it's tempting to feel small, to feel like we live in a universe we barely understand. But there's something comforting about it too. The same hidden forces that shape galaxies also touch us. The atoms in your body exist only because dark matter pulled gas together billions of years ago to form stars that later exploded, scattering the elements that became you. So in a way, dark matter connects everything, the galaxies above, the stars in the night sky, and the consciousness that's looking up at them right now. Every time two galaxies collide, that invisible structure ripples, subtly reshaping the fabric of the universe. The merger isn't just between two systems of stars, it's between two gravitational identities, two invisible skeletons coming together to form a new one. And though we can't see it, we can feel its effects everywhere. The steady hand of dark matter keeps galaxies whole, guides their motion, and ensures the cosmic dance continues, silently, elegantly, endlessly. If you've made it this far into the story, you're already seeing the universe differently, not just as a place of light, but as a place shaped by the unseen. If you're enjoying this journey through space and time, take a moment to like the video and subscribe. It really helps the channel reach more curious minds who love exploring the mysteries of existence, just like you. Now, we've talked about the invisible hand guiding the galaxies. But what happens in the places where that invisible hand grips the hardest, where gravity pulls gas and dust so tightly that stars are born in brilliant waves of light? That's where we're going next, into the heart of chaos, where galactic collisions become cosmic nurseries, and destruction gives birth to light. When galaxies collide, we often imagine chaos, stars smashing, worlds ending, destruction on an unimaginable scale. But in truth, what happens next is one of the most creative, spectacular, and life-affirming processes in the universe. Out of apparent ruin comes light. Out of gravitational chaos comes birth. When two galaxies begin to merge, the enormous clouds of gas and dust within them collide head-on. Unlike stars, which are mostly empty space, these clouds actually touch, compressing and folding in on themselves under the crushing pressure of gravity. And in that compression, that moment of collapse, stars are born. It's called a starburst, and it's one of the most extraordinary events in the cosmos. Picture it, massive molecular clouds, each dozens of light years wide, squeezed tighter and tighter until gravity ignites fusion. New stars flare to life in great clusters, flooding their surroundings with ultraviolet light. These regions glow like embers scattered across the galaxies, each one containing thousands, sometimes millions of newborn suns. For a while, these merging galaxies shine brighter than they ever have before. They become cosmic fireworks displays, starburst galaxies, dazzling the universe with their brief but brilliant light. The beauty of it all is that this chaos is necessary. Without collisions, many galaxies would grow cold and dim. Their gas would settle into quiet, uneventful orbits. But a merger shakes everything awake. It stirs up the gas, rekindles star formation, and breathes new life into galaxies that might otherwise fade into silence. Astronomers have captured these scenes in stunning detail. The Hubble Space Telescope, and now the James Webb Space Telescope, have shown us starburst regions so vivid they look almost unreal. Massive blue-white clusters surrounded by pink clouds of glowing hydrogen. These are nurseries of light, places where the raw materials of existence are transformed into stars and eventually into the elements that make up planets, oceans, and living things. But these starbursts don't last forever. Like fireworks, they burn hot and fast. Within just a few 100 million years, a blink of cosmic time, the available gas is consumed or blown away by the radiation and winds from the very stars that were just born. Massive young stars live fast and die young, exploding as supernovae that scatter heavy elements across the merging galaxy. These explosions carve out huge cavities in the gas clouds, sending shock waves rippling through the interstellar medium. And those shock waves, in turn, trigger more star formation. It's a cycle, a self-propelling rhythm of creation and destruction, all unfolding within the grander collision of galaxies. Imagine standing, if one could stand, somewhere inside one of these colliding galaxies. You'd see regions of the sky blazing with light. Dozens of new stars would be born every second. The radiation would be intense. Clouds of glowing gas would stretch across the heavens like colorful veils. The sight would be magnificent, but it would also be deadly. The energy released by young stars and supernovae would make nearby regions utterly inhospitable to life as we know it. But farther away, at the quieter edges of the merging galaxies, things would be different. There, gravity's influence is gentler, the chaos more distant. Some planetary systems would remain stable, their stars undisturbed, their planets circling peacefully, even as the galaxies around them transformed. It's within these safe zones that the next generation of stars and planets could form, enriched by the heavy elements scattered by supernovae, the very ingredients needed for life. In this way, galactic collisions are not just acts of destruction, they're engines of creation. Every star, every planet, every molecule of carbon and oxygen in your body was once part of this cycle. Somewhere, billions of years ago, galaxies merged, gas clouds collapsed, and new stars formed. One of those stars became our Sun. Around it, dust and rock gathered into planets. And on one of those worlds, life began to wonder where it came from. So when you look up at the night sky, every point of light you see is the product of countless cosmic collisions, ancient starbursts frozen in time. Each star carries within it the memory of the chaos that gave it life. Astronomers have even found galaxies in the middle of these transformations, like the Cartwheel Galaxy, with its brilliant outer ring of newly formed stars expanding outward from a central collision. It looks like a ripple spreading across the surface of a pond, but the pond is 150,000 light-years wide, and the ripple has been traveling for hundreds of millions of years. Inside these galaxies, new worlds are being born right now. Somewhere, in a newborn cluster of stars, planets are forming from disks of dust and ice. Some of those planets may already have oceans, clouds, even atmospheres rich in the elements scattered by long-dead stars. And perhaps someday, some of them will evolve beings who look up at their own night sky and wonder where they came from, never knowing that their galaxy was once too. When we speak of creation in cosmic terms, it's hard not to feel a sense of awe. The scale is unimaginable, and yet the principles are simple. Gravity pulls matter together, pressure and time ignite fusion, energy reshapes the surroundings, and through it all the universe builds complexity, step by step, atom by atom. In a very real sense, collisions make the universe what it is. Without them, galaxies would grow lonely and stagnant. But because they meet, they evolve. They give rise to new generations of stars, new places where life can emerge, and new light that will travel across the cosmos for billions of years, perhaps to be caught by a telescope or by your eyes on a quiet night. The next time you see a photograph of colliding galaxies, those spectacular whirlpools of light and shadow, try to imagine what's happening within them. Think of the newborn stars, the swirling gas, the unseen hand of gravity shaping everything. Every pixel of light in that image represents millions of stories. The birth and death of stars, the forging of elements, the constant recycling of cosmic material. And when you realize that your body, your breath, and even your thoughts are made from the same atoms forged in those long-ago collisions, it becomes hard not to feel connected to everything. You are, in a literal sense, the universe remembering itself. This is what makes galactic collisions so beautiful. They're not just distant spectacles. They are acts of renewal, proof that even in the cold and silent depths of space, creation never stops. If you're enjoying this cosmic journey, take a moment to subscribe and stay tuned, because what happens at the very heart of these colliding galaxies is even more mysterious. There, where gravity becomes almost infinite, lie two of the most powerful objects in existence, black holes. And when galaxies merge, so do they. That's where we're headed next, into the heart of darkness itself, where time bends, matter vanishes, and gravity sings the deepest notes of the cosmic symphony. At the very heart of every massive galaxy lies a secret, a single invisible object with the mass of millions, sometimes billions of suns, a supermassive black hole. For the most part, it rests quietly, hidden behind veils of dust and light, influencing everything around it with its immense gravity. It shapes the motion of stars, regulates the flow of gas, and anchors the entire galaxy together. Now imagine what happens when two of these titans meet. As galaxies collide, their supermassive black holes begin an invisible dance of their own. At first, they're separated by tens of thousands of light years, orbiting each other slowly, like ancient predators circling in the dark. The surrounding stars and gas feel their pull. Over time, the black holes spiral closer and closer, their immense gravity stirring the space between them like a whirlpool. Each black hole is surrounded by an accretion disk, a blazing ring of gas, dust, and matter falling inward at nearly the speed of light. As these disks interact, magnetic fields twist, radiation erupts, and colossal jets of plasma shoot out from their poles, stretching across light years. These jets can outshine entire galaxies. They are among the brightest phenomena in the universe, beacons that mark where space itself is being torn apart. It's easy to think of black holes as destroyers, but in truth, they are sculptors. Their gravitational power shapes galaxies, drives star formation, and redistributes matter across space. In a collision, this power multiplies. For millions of years, the two black holes drift closer, locked in a gravitational embrace. Around them, stars are flung outward by tidal forces. Some hurled into intergalactic space, others drawn into tight, chaotic orbits. Each orbit, each encounter, bleeds energy away from the system. The black holes lose momentum. They spiral tighter. The dance quickens. And then, when they're only a few light years apart, something extraordinary happens. The very fabric of space-time begins to ripple. These ripples are gravitational waves, distortions that stretch and squeeze space itself, traveling outward at the speed of light. They were predicted by Einstein in 1916, but not directly detected until a century later. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, captured the faint tremor of two black holes merging a billion light-years away. The signal lasted just a fraction of a second, but it was enough to confirm that space and time are not static. They can move, flex, and sing. Now imagine that, but on a galactic scale. When two supermassive black holes merge, The energy released in gravitational waves can exceed the light energy of all the stars in the observable universe combined. For a brief instant, the universe itself vibrates with their collision. And yet, if you were watching from a safe distance, you wouldn't see much. There would be no flash, no explosion. Just a quiet tremor rippling through space-time, spreading invisibly across billions of light-years. That's the paradox of the cosmos. The most violent events are often the most silent. Scientists are now searching for these signals. The next-generation observatory called LISA, the Laser Interferometer Space Antenna, will orbit the Sun, waiting to catch the low-frequency ripples produced by merging supermassive black holes. It will be humanity's ear pressed against the edge of eternity, listening to the deep bass notes of creation. Each signal will tell a story, not just of two black holes colliding, but of the galaxies that carried them together, the stars that danced around them, and the cosmic history written in their gravitational song. When the merger is complete, what remains is a single, larger black hole, heavier and more powerful than either that came before. Around it, the galaxy settles into a new shape, often elliptical, smooth and ancient-looking. The chaos fades, the light dims, and a new equilibrium emerges. The galaxies are gone. What remains is one. But the story doesn't end there. The newly merged black hole begins to shape its surroundings again. It feeds on the leftover gas and dust, igniting once more into a quasar, a cosmic lighthouse that can be seen across the universe. Quasars are powered by these very mergers. They are the visible fingerprints of cosmic transformation. Each one marks the moment when galaxies become something new, when matter and energy are redistributed on the grandest scale imaginable. And though it may seem distant and abstract, this process is part of the same cosmic chain that eventually led to our own existence. You, sitting here now, listening to this story, are made of atoms forged in the hearts of stars, stars that would not have existed without the gravitational cycles of birth, collision, and renewal that black holes help orchestrate. It's strange to think of it that way. The same forces that tear galaxies apart also make planets and people possible. Destruction and creation are not opposites in the universe. They are two sides of the same endless process. And so, while we marvel at the spectacle of black holes merging, what we're really witnessing is the universe doing what it has always done. Changing, evolving, transforming. Each collision writes a new chapter in the grand story of existence. The Milky Way and Andromeda each have supermassive black holes at their centers. In roughly 4-5 billion years, they will meet. They will spiral toward one another for eons before finally merging in a spectacular release of gravitational energy. The result will be a new, larger galaxy, sometimes called Milkomeda, with a single, even more massive black hole at its heart. And though our sun will by then have begun to fade, the light of that merger will travel across the cosmos, a whisper of gravity echoing through time. Perhaps some distant civilization, billions of years from now, will detect it. They'll study the waves, analyze the data, and realize that two galaxies once collided long ago, and that one of them was ours. It's humbling, isn't it, to know that even our galaxy is part of this vast, ongoing story, that nothing in the universe is truly permanent, not stars, not galaxies, not even space and time themselves. Everything changes, everything flows. So the next time you see an image of a galaxy, serene, majestic, eternal, remember that it's only a moment in an endless dance. Somewhere out there, two more are already on a collision course, slowly, silently, inevitably drifting toward each other. And within that slow-motion meeting lies the seed of something new. If this journey through the cosmos has captured your imagination, take a moment to like this video and subscribe to the channel. It helps us keep exploring these questions together, questions that connect science, philosophy, and the quiet wonder of being alive in a universe that never stops creating. Because after the chaos, after the light and the gravity and the merging of black holes, something unexpected begins to emerge: order, a new kind of galaxy reshaped by the collision. And in the next part of our journey, we'll explore what happens when the universe recycles its chaos into beauty once again. Right now, if you step outside on a clear night and look toward the constellation Andromeda, you can see a faint, misty patch of light, just barely visible to the naked eye. That smudge is another galaxy, too. 5 million light-years away. It's the most distant object you can see without a telescope, and it's coming straight for us. The Andromeda Galaxy and our Milky Way are moving toward each other at a speed of nearly 250,000 miles per hour. It sounds fast, and it is, but on cosmic scales, this is the gentlest of motions. It will take roughly 5 billion years before the two galaxies finally collide. For now, we have time. Still, it's strange to think about. The sky above you, the familiar band of the Milky Way arching from horizon to horizon, is not a fixed thing. It's part of a living system, one that's slowly, silently on a collision course with its nearest galactic neighbor. Let's imagine what that future will look like. The first signs will be subtle. Over the course of millions of years, Andromeda will appear larger in the night sky. What now looks like a faint blur will grow into a bright, glowing disk, easily visible even in daylight. Future astronomers, whoever or whatever they may be, will watch as the great spiral arms of Andromeda stretch across the heavens, glowing faintly in shades of blue and silver. Then, over tens of millions of years, the two galaxies will begin to distort each other. Their shapes will twist and stretch. Vast tidal tails of stars and gas will arc across the sky, connecting the two in a bridge of light. Entire constellations will change. The night will no longer look familiar. Instead, it will be filled with ribbons of stars, shimmering traces of gravitational tides. From the perspective of Earth, the view will be breathtaking. There will be no sudden crash, no fiery explosion. The stars are far too distant from one another to collide. Instead, they will drift gracefully through each other, like two swarms of fireflies passing in the dark. The galaxies will merge in slow motion over billions of years, creating a vast new shape in the sky, a single, enormous elliptical galaxy, glowing with the combined light of 1 trillion stars. But what about us? By the time this happens, the sun will be nearing the end of its life. It will have grown hotter and brighter, possibly scorching the Earth's surface. Life, as we know it, may no longer exist here. But that doesn't mean we can't imagine what the sky would look like if we could stand and watch. In the early stages of the collision, the Milky Way's familiar shape will begin to blur. Great arcs of stars will stretch outward. The galactic center, the dense, golden bulge at the heart of our galaxy, will merge with Andromeda's, glowing like twin beacons. The sky will be filled with light. Where once we saw thousands of stars, we will see billions. The night will no longer be dark. And somewhere in that grand ballet, our solar system will be caught up in the motion. It's possible that the sun and its planets will be thrown into a new orbit, farther from the galactic center, perhaps even ejected into intergalactic space. Or maybe we'll remain bound within the new galaxy, circling a different core beneath a sky filled with unfamiliar constellations. Either way, it won't be the end. It will be transformation. Astronomers have simulated this process using powerful computers, compressing billions of years into seconds. In those simulations, the two galaxies swirl together like liquid smoke, twisting, blending, and finally settling into one luminous form. When it's over, the Milky Way and Andromeda will no longer exist as separate entities. They'll be one, a new massive elliptical galaxy, glowing softly in the dark. Scientists have already given it a name, Milkomeda. It will be quieter, calmer, and rounder than either of its ancestors. The wild spiral arms will fade, replaced by a smooth halo of stars. The furious bursts of new star formation that accompanied the merger will slow. The galaxy will grow old, bathed in the soft light of billions of aging suns. It's an ending, but it's also a beginning, because even as old stars fade, new ones will continue to form. Some of them will have planets, and some of those planets might, someday, look up and see a sky filled with the ghostly remnants of two galaxies that once collided, the faint echoes of their birth written across the stars. In a way, the future collision between the Milky Way and Andromeda is a reminder that nothing in the universe is fixed. Even the vastest structures are temporary. They are always changing, merging, evolving. The cosmos itself is fluid, a constant state of becoming, and as vast as that timescale is, there's something deeply human about it, because we, too, are part of that cycle. Our atoms were born in stars that lived and died long before the Milky Way took its current shape. And someday, those same atoms, now part of us, may drift again through the galaxy, carried by the winds of time, waiting to be born into something new. When you think about it that way, the coming collision isn't something to fear. It's something to marvel at. It's a reminder that creation and destruction are woven together in a single, endless dance, one that began long before us and will continue long after. And if there's something poetic in knowing that our galaxy's final act will be to merge with another, it's that the universe itself never stands still. It moves toward connection, toward unity. So when you look up tonight and find Andromeda in the sky, that faint oval of light, remember that you are looking into the future. That's our destination. Our galaxies are already moving toward each other, guided by the invisible hand of gravity. The dance has already begun. And though we won't be here to see its conclusion, we can still be part of its story, simply by imagining it. Because to imagine is to reach across time, to glimpse what will someday be, and to recognize that, even in a universe of endless motion, wonder never fades. If you're enjoying this journey through space and time, take a moment to like this video and subscribe to the channel. It helps us continue exploring the grandest questions, the ones that remind us that we are small, yes, but not insignificant. Because even as galaxies collide and stars are born and die, there's one constant that endures: curiosity. The simple, enduring human desire to understand the universe we came from. And that curiosity leads us to our next chapter, where we'll see that from every cosmic collision, something new and beautiful emerges. When the chaos of collision begins to fade, when the brilliant storms of starbirth settle and the gravitational waves quiet, something remarkable starts to happen. From the wreckage of two galaxies, a new cosmic structure begins to take shape. The universe, even in its violence, always tends toward creation. Every act of destruction is also an act of recycling, of renewal. When galaxies collide, they don't simply vanish into chaos. The stars, gas, and dark matter that once belonged to two separate systems begin to mix, merge, and stabilize. Over millions of years, gravity reshapes them into a new, unified whole. The process is slow, like clay being molded by invisible hands. The wild arms of a spiral galaxy begin to fade. The intricate structure that once defined it, the elegant swirl of its disk, is gradually erased by the collision's turbulence. The result is smoother, rounder, and more diffuse. This is how elliptical galaxies are born. Vast, golden spheres of ancient stars glowing softly in the dark. In the beginning, they shine brightly. The intense bursts of star formation triggered by the merger fill them with young, massive stars, brilliant blue giants that burn with furious light. But these stars live fast and die young. Within a few 100 million years, they explode as supernovae, seeding the galaxy with heavy elements: carbon, oxygen, iron, gold, the ingredients for future planets, for future life. As time passes, the galaxy's light changes. The bright blue glow fades, replaced by the warm, steady shine of older, redder stars. Star formation slows, then almost stops. The galaxy becomes quieter, gentler, a city of aging suns, each drifting in calm orbits through a vast sea of starlight. But the story doesn't end there. Even in this apparent calm, the remnants of the collision continue to shape the future. Streams of gas stretch outward from the new galaxy, like rivers feeding the intergalactic medium. These streams carry with them the building blocks for the next generation of stars and galaxies. Gravity doesn't waste anything. Over billions of years, this scattered material will fall back inward, condensing into new systems, smaller galaxies, star clusters, perhaps even the seeds of new solar systems. In this way, the universe continuously reuses its own matter. Nothing is ever truly lost. If you could watch this process unfold over cosmic time, you would see the new galaxy pulsate with slow, rhythmic activity. Stars die, explode, scatter their ashes, and from those ashes, new stars are born. Dust becomes planets. Planets become homes, homes become memories. And eventually, all of it, every atom, every photon, every trace of life, returns to the cosmic sea, waiting to be shaped again. It's a cycle that never stops. Destruction becomes creation, chaos becomes order. The universe breathes in and out endlessly. When scientists look at the night sky, they can trace this cosmic recycling in real time. The elements we detect in distant galaxies, hydrogen, helium, oxygen, iron, tell a story of countless generations of stars. The oxygen you're breathing right now was forged in a star that lived billions of years ago, perhaps in a galaxy that no longer exists. The calcium in your bones, the iron in your blood, the gold on your skin, all of it is stardust. You are quite literally the recycled material of ancient collisions. Every atom has a history that stretches back through time. Maybe the carbon in your DNA was once part of a star in a small, forgotten galaxy that merged with the Milky Way billions of years ago. Maybe the oxygen in your lungs once drifted through intergalactic space, torn free from its home by the gravity of a passing galaxy. Maybe the gold in a ring on your finger was born in the collision of two neutron stars, themselves the remnants of earlier cosmic deaths. When you see the universe this way, everything becomes connected. Every explosion, every merger, every flicker of light has meaning. Nothing is wasted. In the new galaxy that emerges from a collision, the central supermassive black hole, the remnant of the merging pair, continues to influence everything. It stabilizes the system, drawing stars into gentle orbits. Occasionally, it feeds again, devouring a drifting cloud of gas and flaring to life as an active galactic nucleus, sending jets of energy thousands of light years into space. These outbursts help regulate star formation, preventing the galaxy from collapsing under its own gravity. Even in apparent silence, the black hole continues to sculpt and balance the system. Over billions of years, this balance deepens. The galaxy becomes mature, neither too chaotic nor too still. The storms have passed, leaving behind a kind of cosmic calm. It is, in a sense, the galaxy's old age, a time of quiet reflection after a lifetime of creation and transformation. And yet, even in this stillness, the seeds of the future remain. The gas expelled into intergalactic space may someday fall into another region of gravity, sparking the formation of new stars, new worlds, and perhaps new life. The cycle continues endlessly, each generation building upon the last, carrying forward the same atoms, the same energy, reshaped into new forms. When we look at galaxies today, whether they're spirals, ellipticals, or irregular, we're seeing snapshots in that grand cycle. None of them are permanent. Each one is a temporary arrangement of matter, a moment in the long story of cosmic evolution. Even our own galaxy right now is not the first form it has taken, and it won't be the last. It has absorbed countless smaller galaxies over billions of years, each one leaving traces in the stars we see today. The Milky Way is already a mosaic, a collection of stellar memories, layered one atop another. That's what collisions do. They don't end galaxies, they create new ones, stronger, richer, and more complex than before. And if you think about it, that pattern mirrors life itself. Growth comes from change, transformation from chaos. The universe, in its vastness, follows the same principle that we see reflected in our own existence. From every ending comes a new beginning. So when we talk about galaxies colliding, we're really talking about the universe's way of growing, of recycling its matter, its light, and its stories. It's a process that has been happening since the dawn of time and will continue long after our world is gone. Every photon that reaches your eyes, every particle that makes up your body, every breath you take, all of it has passed through this cycle countless times. You are not separate from the universe. You are the universe, experiencing itself, remembering its own story through you. If that thought fills you with wonder, take a moment to like this video and subscribe to the channel. It helps us keep exploring these cosmic truths together, not just as facts, but as experiences of awe and connection. Because in the end, every galaxy, every star, and every being that has ever existed is part of the same beautiful process, the universe learning to become itself. And in our next chapter, we'll look closer at what makes that process possible, the fundamental force that drives it all, the one that holds galaxies together and shapes the flow of time itself: gravity. At the heart of every collision, every orbit, every dance of stars, there is one simple, unstoppable force: gravity. It's easy to take it for granted. We feel it every moment of our lives, the steady pull of Earth holding us close. But that gentle tug we know so well is only a faint whisper of gravity's full power. On cosmic scales, it becomes the master choreographer of everything that moves. Gravity isn't just a force, it's the shape of reality itself. Einstein showed us that what we call gravity is actually the bending of space-time, the four-dimensional fabric of the universe. Mass tells space how to curve, and space tells mass how to move. It's a relationship, not a push or pull. Every star, every planet, every particle is tracing the curves of space-time shaped by everything else. Now imagine two galaxies drifting through that curved landscape, each wrapped in a halo of dark matter, invisible, massive, and vast. Their gravity fields reach out far beyond their visible edges, interlocking long before the galaxies ever touch. The moment those fields connect, the dance begins. Stars begin to change their paths, bending subtly toward the approaching mass. Gas clouds shift, drawn into new orbits. Time itself, near each galaxy's core, slows by a fraction, warped by the immense gravity of the supermassive black holes that anchor them. From a distance, it looks slow, almost motionless. But that's because gravity plays its symphony in deep time. On human scales, seconds tick. On cosmic scales, entire civilizations could rise and vanish in the time it takes two galaxies to move a single step closer. A collision that seems frozen in the stillness of space is actually a vast, slow-motion ballet, every motion governed by gravity's invisible hand. The physics behind it is astonishingly precise. When two galaxies approach, their mutual gravity creates what's known as tidal forces, differences in gravitational pull that stretch and twist their shapes. The same kind of force that moves the tides on Earth can rip apart entire star systems when magnified to cosmic proportions. These forces fling out long tendrils of stars, creating the spectacular tidal tails we see in images from the Hubble and James Webb telescopes. Yet, for all its power, gravity is patient. It doesn't rush. It works through time, shaping, folding, and guiding matter toward balance. It's the great sculptor of the cosmos, carving beauty from chaos, using nothing but motion and time. Time, that's the other half of the story. In the universe, gravity and time are inseparable. The stronger the gravity, the slower time passes. Near a massive object, like a black hole, seconds stretch into minutes, minutes into hours. In regions of weaker gravity, time flows faster. This isn't just theory, it's been measured, tested, proven. So when two galaxies collide, they don't just distort space, they distort time itself. Each star, each atom, each photon is moving through a slightly different rhythm of reality. The universe, in that moment, becomes a cosmic symphony of clocks, all ticking at their own pace.